Today, we're diving into one of the cleverest tricks in the entire world of AI. It's a method that lets us build incredibly powerful, specialized artificial intelligence without starting from square one every single time. It's called transfer learning, and it's a total game changer. I mean, let's be real. Building a truly smart AI model from scratch can feel like an impossible climb up a mountain. You need just mountains of data and an absolutely insane amount of computing power. But what if there was a way to just, take a helicopter to the top? So here's how we're going to break it down. First, we'll look at just how big this mountain really is. Then, we'll introduce the genius shortcut that changes everything. We're going to pop the hood to see how it works, put it to the test with real results, and finally, see how this idea is already changing the world around us. Okay, let's get into it. Part 1, the big AI challenge. Just how hard are we talking when we say you want to train a brand new AI model from absolute zero? Well, it's a massive undertaking, seriously. To teach an AI just to recognize images, you need these gigantic data sets. Take something like ImageNet. We're talking over 14 million images, every single one labeled by a person. And then you have to throw just a ridiculous amount of computing power at it, often for weeks, sometimes even months straight. For most people, that's just not possible. Right, but that huge problem brings us to the really cool part, the genius shortcut. What if you didn't have to reinvent the wheel every single time? What if you could just borrow knowledge that's already out there? And that's the beautiful idea behind transfer learning. You take an AI that's already an expert at one thing, say identifying thousands of everyday objects, and you use its brain as a starting point to learn a new related skill, like telling the difference between a golden retriever and a Labrador. You're not starting with a blank slate, you're starting with a ton of experience already baked in. It really is the perfect example of that old saying. Instead of having to build your own giant from the ground up, you just get to climb on top of one that's already there. It gives you an unbelievable head start. So, that all sounds great, but how does it actually work? Let's get into our third section and take a look under the hood to see what's really going on.
The whole process is actually pretty elegant. It's almost like a brain transplant. First, you start with a powerful, pre-trained expert model. A popular one is called VGG16, which knows all about those ImageNet photos. Then you basically snip off the very last layer, the part that was hyper-specialized on its old job. Step 3, you freeze pretty much the entire model. This locks in all that foundational knowledge about edges and textures and shapes. Then you bolt on a new small custom part that's built just for your task. And here's the magic. You only have to train that tiny new piece.
So the key takeaway is this. By freezing the main body, you're protecting all that fundamental wisdom it got from seeing millions of pictures. You're not teaching it how to see all over again. You're just teaching the new part how to use that existing knowledge on your much smaller set of images. In this experiment, a little data set called CFAR10. This trick saves an unbelievable amount of time and resources. Okay, so that's the theory. But, does it really work in practice? Time for part 4. Let's put this shortcut to the test and see what happens. And the result? A whopping 77% accuracy. After this super quick process, the model could correctly classify images from a totally new data set it had never seen before. It's just a fantastic proof of concept for what happens when you build on a strong foundation instead of starting from scratch. But here's the real kicker. It hit that 77% not after months of training, but after just 10 quick passes through the data. They're called epochs. We're talking the difference between running a marathon and a quick sprint. It's not just powerful, it's ridiculously efficient. And when you look at it like this, the difference is just night and day. If you tried to train from scratch with that tiny data set, your accuracy would be, pretty terrible. But with transfer learning, we jump way up to a really respectable performance with just a fraction of the work. All right, which brings us to the big finale. Why does any of this matter outside of a lab? How does this amazing shortcut actually impact our real lives? This is where transfer learning goes from a cool trick to an absolute game changer. Think about medical imaging, where you might only have a few scans from patients to diagnose a rare disease. Or autonomous vehicles that need to be fine-tuned to recognize local road signs. It can even be used to identify products on a store shelf. Basically, anywhere data or computing power is limited, this technique unlocks the door to powerful AI for everyone. It really gets you thinking, doesn't it? We've managed to teach a machine one of our most human tricks, learning from past experience. If we can do that so well with vision,
What's next? What's the next great human shortcut we're going to teach our machines?